Okay, so then let's start with this overview of the computing services, everything we offer. I think our first slide is always this nice photo. I think it's probably already maybe 4 or 5 years old, at least, because we still have the van in there. And this is, of course, the Reading headquarters. Probably some of you had been here already for some other courses or just visits, but this is how it looks as you enter. We always have the flags there, which of course represent the international status of the institution. So wherever we have a site, you tend to also first thing see these flags. So these are the main things for which these computing services are used. No? Of course, we started having operational weather forecasts in the late 70s. I think we've done now our 50th anniversary as an organization. I think the first weather forecast was a bit later than that. Only had the full capability to do it operationally. But this is basically the status as of now. We have this medium range weather forecast that goes up to 2 weeks at the 9-kilometer resolution. It has basically 2 parts: the control forecast, which will disappear soon, what we used to call the high resolution, which was the deterministic one, and then the ensemble one, which is 50 members of probabilistic weather forecasts. I think both are running at the same resolution right now. As I said, the control would disappear soon, and then it would just be an ensemble. Then we have the extended range that goes up to 6 weeks with a lower resolution, and then the seasonal that goes really to the maybe longer and uses the same resolution, but is only produced once a month. And then of course the ocean waves one, that's kind of maritime weather forecast. So all this is produced, and it's probably the main use of our computing systems. We also have this environmental modeling products. So it's Copernicus Climate Change Service. That's also is served from here, from ECMWF, the Copernicus Atmosphere Monitoring Service, and the Emergency Management System. With this, anyway, yeah. So another 2 things we do is this hydrological forecast about floods. They try to detect floods and forecast them. And then a relatively new thing, well, not that new, it was already almost 10 years, but new in the line of things of the evolution, is this fire forecast, this probability of ignition by lighting. So a lot of things. The really newest thing is this is the AIFS, which is the artificial intelligence forecasting system, which is a completely new implementation based on machine learning that is operational since February 2025. Again, here we have 2 versions. One that does is just a, let's not say deterministic, but just creates a single forecast, and the other one, which is an ensemble of 50 perturbed members, the same thing as we used to do with the model. Both at the moment are running at 21 kilometers, and of course this is a fast evolving product. So it's, of course, we can see many new things happening. So we definitely encourage you to track all the developments here. I think there's also a lot of things also in the products, in the graphical products. So it's a pretty good quality thing. Another thing I want to mention is this. We have this forecast user portal in Confluence. So it's basically we're showing that you can search for it probably in the Confluence system as you come in. So we always have all the description of all the forecasting changes, all the new models that are coming, all the new cycles of the model. All this is always described here, also with the changes that happen to the data. This next one is just some kind of description of how the forecast runs use our HPC. So you see that we have 4 main forecast runs: the 12 ETC, 0, then 6, and then 18. So it's higher scale, and I think they take up to 25% of the. Don't quote me on this date, but it is on this figure, but it's more or less something like that of the total computing power. Just the main operation suites of the center, and the rest being used for research and of course for member states, which is where you camp. This is a data flow of how basically. Oops, sorry, this went one too many. Sorry about that. So you see that this is the data flow of all the forecasting system. We have the data acquisition, this scalable acquisition and pre-processing, SAPP. So that gets all the observations, does a pre-processing of that, then that goes into the analysis, that is already part of the model. The analysis generates a forecast, goes to the FDB, which is a disk-based field database. And from that, it gets archived into the Mars system and then disseminated to our actual dissemination happens into our site. This is actually, then users can get the data with different, the Mars client, Web API, open data. Then from the FDB also goes to the product generation based on your requirements as member states. And then the dissemination just sends the data directly through ECPDS to all the different member states. Okay, so now just going into specifically computing services, because that, of course, is all the other. As you know, the main one is the HPC. I will describe this a bit more in detail than in my computer hall virtual tour. But as you may know, this is divided in 4 completely separate complexes. A VAC. So normally you see when you log in which one you land, basically. And this is done to increase reliability, because at any time, any of the 4 complexes can be down and still the service being provided. Of course, the operations and the service to users being provided by the other 3. No? So it helps a lot with of course, our, let's say, our computing center has supposed to be operational and then 24/7 service, differently to other research computing centers that can afford the downtime. No? In our case, downtime. In our case, we cannot. So it's hence all this redundancy. You know? So it's used for serial and parallel workloads. It has Slurm as a batch system, which is very common in many similar systems. And you have different storage systems, options depending on what you need. So basically, normally the trade-off is space, permanence, performance. No? So you tend to have the largest ones are the ones that don't keep the data forever, just have limited permanence. And then they're also normally the slowest. And then from the other end, you have home and perm, just permanent, but you have less space there. And then the software environment, of course, is loaded and used by the module commands. You can switch different versions and different enable and disable different. So the purpose of the HPC is, of course, there's here on the bottom right, they have the running meteorological models. Is of course our own model and our operational run of the forecast, but then of course other member states also run their own. So it's that's another option. And this also is used to access the archives using the Mars command or the ECFS command. We have also what we call time critical applications. I think there will be more description of this later. Is some options we give to you so that you can basically run operational tasks for your organizations directly this in the VLF, but it's still being monitored by our operators. So there are notifications and actions in case something goes wrong. Then of course you can submit jobs. For that you need access to the system, being there, and then do data transfers from the HPC to your organization or back in the other way. Then another very important bit is the data handling system. Of course, this is the robots that load the tapes where Mars and ECFS are living. I think at the moment the total use of the system, I believe, is about over 1 exabyte. I think it's 1 exabyte in primary copy, and then another 300 something petabytes for the backups. So we have 13 libraries at the moment, and each one of them has basically two robots that they can get tapes. So this is where all your Mars requests end up going. Sometimes you may feel, of course, that the Mars access is not as fast, of course, as accessing data from disk, but this is because, of course, there aren't that many of these systems, and there's normally a long queue, and normally what takes the longest time is really to basically find the tape inside the robots, not the ones that are, of course, outside, and just load it into the drives and then read the data. Okay. Yeah. So as I said, in this data handling services, this is hosting Mars, which is this service to access meteorological data, but then also ECFS, which is more file system-like. So it's a system with directories, so you can CD into one. The other is more like an FTP service, I would say. No? And in this one, you can just store any kind of files. No? It's just completely agnostic about what you put on them, just files. And the HPSS is a high-performance storage system, is the actual infrastructure which is underneath Mars and ECFS, and that makes use of all these tape robots. The European Weather Cloud is another service we offer. I think there will be another presentation, I think later today, if I'm not mistaken, about otherwise tomorrow. I don't know. It's another service, but this is more like more similar to maybe what Amazon can provide or Azure, this kind of thing. So it's you basically get an allocation of resources, and on that you can create your own virtual machines and then use for completely different purposes. No? So this is a project that started with EUMETSAT jointly, with the idea that both EUMETSAT and ECMWF will offer very, very similar services with a very similar interface, so that users which are familiar with one can also use the other and with the same similar set of features. And of course, the main, well, there are many advantages of this, but one of them is that it's really close to either ECMWF data or EUMETSAT data, so it's very fast to transfer and process data that is hosted by these institutions. If you have many different services, a website that describes the service, a knowledge base with many articles about how to use it, a specific user support portal to raise questions about this service, discussion platform, and an accounting platform where administrators of this, that including member state administrators, can see the utilization of the resources and how much is left and how many. Okay, so this is basically some numbers of both platforms. So you see they are more or less similar. I think number of cores, number of memory, storage, GPUs. So normally when you get an allocation on this, you tend to get, it's a bit different to the HPC. In the HPC, you have computing time. In the European Weather Cloud, you have resources as in number of cores, amount of memory, amount of storage, amount of GPUs. No? And then every member state has its own, and uncooperating states have their own allocation based on the same criteria that is used to give access to the HPC. So yeah, as I said, more on this. So this is just to so you know that this exists. No? So here we have some examples on applications that have been taking advantage. So it's really, this being just generic hosts, you can do really anything you want. You can run web services, you can run databases, you can do pre-processing, you can do many, many different things. So these are just some example of some member states that found interesting applications there. From networks, yeah, we have some dual links from networks to each of the ECMWF sites. And our provider in the UK is GISC, GAR in Italy, DFN in Germany, for the Bond site. So it's yeah, all a very fast internet connection. So of course, because we are doing massive data transfers, so that's normally, I think we normally don't find that it's a bottleneck for. Sometimes it's maybe the access to data, things like that tend to be the slowest, but the network should be quite okay. Then we have also managing for many, many years the regional meteorological data and communications network, which is a secure and ad hoc network between us and our member states. This, I believe, is going to be discontinued in, I think, in the end of 2026. So, of course, people involved in this probably already knows. But has been, of course, providing a great service for many, many years. Just the last thing, so yeah, we are in the network, we are a participating organization in the EduRoam Federation. That means that if you visit any of our sites and you have an EduRoam Wi-Fi connection, that should work also seamlessly with our in our offices. Yeah, it's a map of the RDCN. These different sites which are connected. I think it's mostly in Europe, but not only. So it's this is kind of dedicated lease lines are between all these points and ASNIM. Yes, so to access ECMWF resources, I will as I told you, we have a presentation directly which is specific about teleport, but just to mention that is you need this multi-factor authentication for use all these services. I think probably many of you already use them for banks or for accessing to your organization, but this is just something that is mandatory. You can follow this link and just to tell you how to set it up. But it's yes, basically directly on our main website in the login side, you have already the option to create them. Let me see, next one. Once you have that, then you can use teleport to get an SSH connection to our HPC directly. So it's I think it's relatively simple to set up. I think so. I will show you later on. But I think the nice thing is that is sessions last for 12 hours, so you only need to do the effective login once every working day normally, and then you can use all the SSH related tools with it, no? Like SSH, SCP, RCP, and all this rsync. All these tools should work. No? It's also possible to do X11 redirection with this, so you can basically run X. We don't recommend it as the main way of using interactive applications because X11 is a protocol not designed to be particularly efficient, just designed to be used in LANs rather than ones. So I mean, just for you to know that it can be used, but then of course for that kind of access, we will recommend VDI, about which we will have a short presentation just after the coffee break. This one is this. So this is this is the VDI. It's a service that can be accessed through that URL, and then you get the full virtual desktop that is running in the Bologna data center. So that is really, you get fast access to all applications. So now just walk through all our web-based services. So this is just an overview, of course. You have the www.ECMWF.int service, which is oriented for everyone's use. You have general news, you have information about training, how to register to events, all of this kind of thing. So it's very recommendable that you keep an eye on it. Then you have the website, which is dedicated for forecasters, but also some other people have access to, which is the EC charts. So it provides you charts and maps and metograms, not only maps, so that the metograms and other types of graphical products. And then you can save your favorites. I think it's very, very useful. Many people is liking it. They have some apps where you can use for downloading data. The Atlassian services that include Confluence, Jira, Bitbucket for anyone having access. So it's this general collaboration tools where we also offer a lot of information there. And then we have some specific websites for CCS, for camps, and for IFAS, for different projects that we are hosting. Open charts, is yet another thing, but it's connected in the www. It's different to EC charts in the sense that it's really open, so it's accessible to anyone, but it's a bit less flexible than EC charts. So you can use it has an API, so you can download remotely and in batch process. So EC chart is very highly interactive, so you can create products in demand. So you have control, for example, of the number of layers you want, the order of layers, the type of geographical area. You can pan and zoom everywhere across the globe. So it also has been optimized along the years, so the performance is pretty good these days for the heavy use of caching and tiling. So I think it is very, very popular for all our member states and other users. So you have the HREST, Ensemble, the Wave products, also of course the machine learning forecast is available there. One particularly interesting product that I think many people like is the Stream Forecast Indices, which is basically uses climatological data to see which unusual weather predictions happen in different places, but weather which is not usual at a particular point and time. So it's it's the same as our computing services is highly available and operationally supported 24/7, so it can be relied really for operational purposes. Okay, So this is an example of the dashboard. So a dashboard is some personalized tool so that you can use to put your favorite products that you're more interested in for your work or personal interests, and then you can put them together in a single page. And then whenever you access the system, you get there, and everything is then, of course, updated to the latest information. It's the product just refers to one type of course of data, but always up to date. For the web services, we have this Mars catalog also. And this is an easy way of navigating all the contents of the Mars catalog, because as you know, of course, the Mars language is very powerful, but can be a bit daunting to use just to discover how to get to some particular type of data. So with this Mars catalog, you can just basically by clicking through, get into the specific type of data, and in the end, just basically a Mars request will be generated for you that you can either use through the web API or just copy and paste to use directly in the Mars command. So we have a lot of documentation also how to access Mars. I think it's a very important element that we always try to insist with people, is to make sure that the requests are done in an optimal way, because of course it's anything that is based on tapes makes a lot of a difference. The way you access, if you access a lot of tapes, it's going to be slower. If you access fewer, it's going to be faster. Then also for anyone accessing the HPC, this interface, the accounting, so you can see how much of your allocation you have used, how much you have left, and the SBU usage in general. Another service is this easy access, which you can access to that URL on the top. This allows to transfer files and then also submit some jobs, some simple jobs right here. And yeah, basically get anything that's in your home, you can also download from here. This is a very important place, the user documentation that is hosted in Confluence. You can access also all this from the support portal. So it's probably the first, whenever you have any question or any thing you don't know about how to access our services, then this is probably the first place to go. So you can just search directly in the search box, or browse by content, or browse by topic. So we are always editing these, adding new articles. We have, of course, generic documentation about products, but also troubleshooting and knowledge base articles, how-tos, how do I do this, how do that, what should I do if I have this kind of problem. So yeah, this is continuously being added to. Yes, so there's, of course, the web services, another lot of documentation in the www website, list of publications, list of our research we do, overview of our computing services. That's something you can get from there, and the science blog. This is also very important. In case you have any problem, we always recommend you to first go to our services status page. You can access this also from the www as part of the ECMWF website. So here you can see if there is any system session or any known problem from any of our users for the services. So in this case, if you see that there's something that we already know, probably it's better not to report anything. Of course, unless it's creating you a really serious operational problem to yourselves. But because it means that we know it and we are on it and we're trying to fix it as soon as possible. But in all cases, it's just a system session. It's an off time that has been booked because some system changes have to be performed, and of course that requires sometimes restarting services and taking them offline for normally a short time. But so yeah, this is important. If you see, for example, you have a problem with a service and here is shown as green dot, meaning that we are not aware of any problem, then of course, by all means, do create a ticket through the support portal, which is this one. So this, as I mentioned before, you have this search box that you can use to search the documentation, the same one that we announced before. And then if you don't find a solution, then just please, you can select in these categories below, navigate to the point that maybe reflects more closely the type of problem you have, because then that helps us with the triage of the issue. So then you can create a ticket, describe what is the problem, and then try to, yeah. So yeah, something we always try to also tell users is to that please provide us as much information as possible of the problem you're having, telling us how you're accessing, which kind of error you're getting specifically, even if you're having problems with something related to data, even provide us a sample of the data, which we can then try to, because that of course will get us a lot faster into the root cause. No? For example, from Mars issue, just provide us the request, the exact request you're sending, and then also all the output that maybe your command or the API is returning. So then, because it's something that we are going to ask you anyway for, so it's good if it comes directly. Okay, so I think this is the end of the first part. I don't know if we have any questions at this point.